Okay, we're going to work with integration by parts, and I've presented you with the formula. If u is equal to f of x and b is equal to g of x, and if the first derivative of f and g prime are continuous, then we can have this formula here. So just a note, this is the integral of u dv is equal to uv minus the integral of v du. Now that doesn't mean a whole lot to you just yet, but we're going to see a proof of this in just a second. And I just added this as an extra. When you're applying a formula, we want to let one part of the integrating correspond to dv, and the other part's going to be u. So the more challenging part most of the time when we start is for students to decide, well, what do I let be u and what part do I let be the dv portion. And so I just kind of jotted this down. We usually designate the dv to be the complicated part of the integrand that can be easily integrated. Okay, so we usually pick that to be the more complicated part, and then we'll let u be the other part. So like I said, that won't make a whole lot of sense until we start getting to some examples and you start seeing things. But let's just take a minute and look at the proof of this. So by the product rule, if I have u and v, two functions, and I take the derivative of it, then it's just first times derivative of second plus second times derivative of first using our product rule. Okay, so if I had this expression and I multiplied all terms by dx, then this would simplify to this expression. Okay, at that point, if I decide to integrate both sides, let's integrate all components, then it would simplify to this line right here. And if I subtract to get the integral of u dv by itself, then here's our expression, which is our formula that I started with. Okay, so let's get down to examples because that's where it really starts to come to light. Well, okay, so here we go. It'll just say evaluate, and then we're going to be working on integration by parts. So if I'm given this, which this part of it, this 5x, is going to just be a polynomial, and this part of it is an exponential. Of course, and one of those include the dx, but this is an exponential part. Then we want to look at this and we need to name one. We want to be able to apply our integration by parts, so we need to determine a u, and then we need to determine which part of it's going to be dv, and using our formula we'll plug that information in over here and calculate this. Okay, so what I want to do first is I'm going to let the u equal to the 5x and the dv equal to the e to the 2x, the exponential part. We usually let dv, and it includes the dx as well. The dv usually includes the dx. Be the more complicated. So of this is a polynomial and this was an exponential. I would think that this is going to be the more complicated part. So we'll let dv be the more complicated part and include the dx, and the u be the polynomial. Okay, so let's just take, what is the derivative of u? 5, and then we have dx. Good. Now over here, we want to know, to be able to calculate this, so this is our u, this is our dv. Right, let me just do that in red. That's the dv. We need a u, a v, and then the integral of v du. So we'll need a v, right? Well, we have dv. How can we find v? Right, if we're willing to integrate and integrate, so then v is equal to, what's the antiderivative of e to the 2x? First of all, it's just going to be e to the 2x, right? Now, if I had the derivative of that, what would that be? 2, and we would account for that 2, which would give us a 1/2. Very good. So if you need to do that step on the side, that's fine. And of course, we would have plus a constant, but we're not going to worry about the plus a constant in this scratch work part. We'll make sure and include that at the very end. Okay, so basically, this step I suggest you collect all your information before you start plugging things in. Okay, so we did our u, we decided our dv, then we determined du, and we would determined our v. Okay, at this point we're ready to come over to our formula and start working. Okay, so I want to evaluate the integral of u dv, which is our expression here, where this is the u, this is the dv. So we're going to calculate. So I'm going to bring down u, which is just going to be our 5x, and then multiply that times v, which is 1/2 e raised to the 2x, minus the integral, and then we have v again, so I'll have 1/2 e to the 2x, and then du, what was our du? 5 dx. Okay, so let's just, I'm going to show every step here. Some of these are some extra steps for you guys, so I'm going to carry down this first term and just leave it as a multiplication expression. And I could pull that 5 out and just have 1/2 e to the 2x dx. Okay, I'm pretty much working to simplify this right hand side, so I'm just going to keep carrying this down until I'm ready to do some work with it. So let's just get we're going to focus on our right term, minus 5. Now let's evaluate what is the antiderivative of this term. Well, first of all, let's just work with this. So it'll be e to the 2x for sure, and then I would account for that too, so I'd have another 1/2, but I have a 1/2 here, so what would that give me? A 1/4. Alright, so at this point I'm going to go ahead and say 5/2 x e to the 2x. Let's be careful not to drop anything off, and then here I'm going to have 5/4 e to the 2x. And then I'm going to go ahead and add plus a constant at this point. Remember I said I didn't put plus a constant here. We would do it at the end. Also, so this is definitely a solution, just so that you can see a factored form. If we pull out a 5/4 e to the 2x out of each term, then that would just leave us with a 5/4 e to the 2x out of this term would leave me with a 2x. And that last term is just a 1. Yes. And then plus a constant. Although feel very confident at this position right here. I'm just showing this in case your textbook may have something factored out, just so you'll see an example of it. But this for sure is a completed solution. Okay, so take a good look at this information and what we've done. And next, on the next page, I'm going to summarize this using a table form of this. So kind of like you could do a check method, or sometimes you can work them this way. So it's the exact same problem, number 1, but using, I'll just rewrite this. So this is number 1. We're going to use table form. I think it's very important for you to be able to take it through the steps in its entirety, but this is also great. So if I was to make a table, first of all, I'll have a u, and I have to decide dv. Okay, so my u we said was going to be what? Think back to the first page. 5x, and the dv is usually the more complicated part, and it includes the dx. But I'm going to leave all those formalities out, okay, and we're just going to work with this. So first of all, you have your u and your dv. The next thing you're going to do is down this side, we want to take the derivative, so differentiate. And on this side, we're going to integrate. Okay, so what would be the derivative of 5x? 5dx, of course, but we said we're going to leave all that technicality stuff out. What would be the antiderivative or the integral of e to the 2x? 1 half e to the 2x. Okay, what's the derivative of 5? 0, so at that point we can say, what is the derivative of 1 half e to the 2x? 1/4 e to the 2x. And the other thing you need to know is that we are going to alternate. This is what we're going to do. We're going to multiply. Let me do it in blue. This times this, right? Multiply right there because that's technically u times v, right? So that represents our u times v, so that's just going to be 5x times 1 half e to the 2x. This one will always be positive, and then the next time when we multiply these two, we're going to use a negative sign, and these will just alternate. So say I went down, kept going, we would positive, negative, positive, negative, positive, negative, okay? So we multiply these two, and then for these two, we're going to subtract the next one. So we'll say minus, not only that, you could see it in our formula how it's come to light. We're already evaluating the integral here, so we're going to have 5 times, we're here, 5 times this term, so that's the 1/4 e to the 2x. And then, of course, we'll have plus c. Now, this step right here basically is what we had here. So it allows us to pretty much go straight from our UDV step to this portion of it and be able to calculate straight from there. Okay, and then it's just going to simplify the same. Okay, so there you go. This is a summary. This was using the table form right here, and so you can kind of check your work with this if you want, or use it as your primary source. Just depends on what your professor prefers at that particular time.